So we need to use the ratio test to determine the convergence or divergence of the given series. So let's find the nth term of this series. So an equals n squared over n plus 1 times n squared plus 2. Then n plus 1's term of this series, an plus 1, equals n plus 1 squared over n plus 2 times n plus 1 squared plus 2. Then the limit of the absolute value of an plus 1 over an, where n approaches infinity, equals limit of the absolute value of n plus 1 squared over n plus 2 times n plus 1 squared plus 2, and multiplied by n plus 1 times n squared plus 2 divided by n squared, and n approaches infinity. Let's try to simplify this a little bit. So this equals the limit of the absolute value of n squared times 1 plus 1 over n squared, and here we have n cubed times 1 plus 2 over n times 1 plus 1 over n squared plus 2 over n squared, multiplied by n cubed times 1 plus 1 over n times 1 plus 2 over n squared divided by n squared, and n approaches infinity. Then this equals the limit of the absolute value of 1 plus 1 over n squared over 1 plus 2 over n times 1 plus 1 over n squared plus 2 over n squared, multiplied by 1 plus 1 over n times 1 plus 2 over n squared over 1. Then, since we know that n approaches infinity, that means that 1 over n approaches 0, 2 over n approaches 0, 2 over n squared also approaches 0. So we get that this equals 1 plus 0 squared times 1 plus 0 times 1 plus 0 divided by 1 plus 0 times 1 plus 0 squared plus 0 times 1. So this equals 1. So we get that the limit of an plus 1 over an equals 1. That means that the ratio test fails here. Ratio test fails, and that's why we will use the comparison test. So let the given series, let me copy paste it. So the given series, let's call it series an. So this is an, where n goes from 1 to infinity. So we get that an equals n squared over n plus 1 times n squared plus 2. Then bn, series bn equals the series of 1 over n, where n goes from 1 to infinity. So we get that bn equals 1 over n. And now, using the comparison test, the limit of an over bn, where n goes to infinity, equals the limit of n squared over n plus 1 times n squared plus 2 times this whole thing is multiplied by n, and n goes to infinity. Then this equals the limit of n cubed over n cubed times 1 plus 1 over n times 1 plus 2 over n squared, where n approaches infinity. Since n approaches infinity, then 1 over n and 2 over n squared approaches 0, so we get that this equals 1. So the limit of an over bn is positive and finite. We know that bn equals 1 over n, so using p-series test, we get that series bn is divergent. And according to the comparison test, series an is also divergent. So that means that our initial series, our given series, is divergent.